Episode 164 of CppCast with guest Gordon Brown, recorded August 22nd, 2018. This episode of CppCast is sponsored by PVS Studio, one of the most powerful static analyzers for your C, C++, and C# source code. PVS Studio will let you detect errors and potential vulnerabilities at the earliest stage. Try the demo version today at viva64.com. In this episode, we discuss CppCon posters and the new Boost library. Then we talk to Gordon Brown from CodePlay. Gordon talks to us about SYCL and his contributions to the OpenCL abstraction layer. Welcome to episode 164 of CppCast, the first podcast for C++ developers by C++ developers. I'm your host, Rob Burving, joined by my co-host, Jason Turner. Jason, how you doing today?
I'm all right, Rob. How are you doing?
I'm doing good. Down to just over 1 month until CppCon, right?
Yes. Wow. Yes, that's about right. So I figured I should probably go ahead and mention, because I haven't spent too much time talking about it, that I have said I am giving 2 talks. Mm-hmm. The first one, the schedule's officially out now. On Monday, Surprises in Object Lifetime. And then on Friday, so I kind of get the chance to bookend the conference,
nice.
Is Applied Best Practices.
Mm-hmm.
The concept is, I just started a project from scratch, and I want to use all the best practices that I teach. What happens?
Right. And
so then on that note, I am doing 2 days of best practices training at the end of the conference as well. And there is still time to sign up for classes, and we'll talk more about classes with our guest today.
Yeah, definitely. Okay, well, yeah, you should definitely sign up for Jason's class and check out all the CppCon classes that are available if you're going to be going to the conference.
There is a large set of offerings this year, for sure.
Yeah. Well, top of our episode, I'd like to read a piece of feedback. This week we got an email from Henrik. He says, "Hi from Norway. Love your podcast. Keep up the good work. As an ex-troll, I was hoping to promote pronouncing cute the right way," which he phonetically spelled out as cute. I'm reading that the right way, right, Jason?
Yeah, as far as I know. And for the record, I think most people do know that it's cute, but we all feel a little weird saying it because we're not sure if other people will know what we're talking about.
Right. It's sometimes just easier to say the letters so people know exactly what you're saying.
But I'm using a cute GUI toolkit. Okay, which one? Cute. It becomes at least in English anyhow.
Yeah, it can be confusing, but I will try to remember this note, and I will try to remember to pronounce it as cute whenever we talk about the GUI framework on the show.
Yeah.
Well, we'd love to hear your thoughts about the show. You can always reach out to us on Facebook, Twitter, or email us at feedback@cppcast.com, and don't forget to leave us a review on iTunes. Joining us today is Gordon Brown. Gordon is a senior software engineer at CodePlay Software in Edinburgh, specializing in designing and implementing heterogeneous programming models for C++. Gordon spends his day working on Compute CPP, CodePlay's implementation of SYCL, and contributing to various standards bodies, including the Kronos Group and ISO C++. Gordon also co-organizes the Edinburgh C++ user group and occasionally blogs about C++. In his spare time, Gordon enjoys dabbling in game development, board games, and walking with his 2 dogs. Gordon, welcome to the show.
Hi there, thanks very much for having me on.
So this is, if our listeners are not paying attention here, keeping track, the 3rd guest from CodePlay that we have had on in as many months. Now, this was not planned from our perspective, but we have to know if you all secretly planned this and didn't tell us.
It wasn't intentional. It just kind of happened that way. So I've been meaning to come on for a while, but sort of work kept getting in the way.
So it all just coincidentally lined up like this, basically.
Yeah. So, but when I sent the email to ask about coming on, I think I didn't realise that Chris and Simon were also planning to come on in the same month.
Yeah.
It does seem like there's a lot of interesting things going on there at CodePlay, and which of course we'll talk about more what you are doing there when we get into the interview. But it seems like you all are having a good time anyhow.
Yeah, there's a lot of really interesting things happening, a lot of interesting projects, and there's a lot of people that are very involved in C++ and the standards and the community. So
that's cool.
Okay, well, we got a couple news articles to discuss, and feel free to comment on any of these, and then we'll talk more about the work we're doing at CodePlay and SYCL, okay? Okay, so this first one, we're mentioning CppCon already. They just announced the poster program, and they have chosen, I think, 16 different entries for this year.
Yeah.
How, is that a lot? I mean, it seems like, I remember like 2 years ago when I went, I think there were only like 5 or 6 maybe.
Yeah, 2 years ago, I was a judge, and I think there was like 6, and it was like impossibly difficult to choose who the winners were. I cannot even imagine what it would be like doing these like 15 or 16 or whatever it is.
Yeah. And they do have all the poster titles and the authors of those posters. I see at least one previous CppCast guest on here, Elena Sagaleva. I'm probably not saying that right, but she's the one who made the C++ lambs, and I guess she's making a poster based on that.
Yeah, that looks like fun. I recognized her, and then the only other project I recognize is Clang Power Tools, I think. Everything else looks like it's going to be interesting, pretty unique, as far as stuff that I'm aware of.
Yeah, there's a lot of variety there. There's a lot of really interesting posters.
Yeah.
I think there's one I noticed on memory tagging for improving safety. That sounds quite interesting.
Yeah.
I'd also like to know what Funky Pools is about. It's a very abstract poster title.
And it's in all caps, too. It's not just Funky Pools.
Yeah.
It's Funky Pools.
Yeah. Okay. Next thing we have is this blog post from Borislav Stanmarov. And he writes about a bug in the C++ standard, although after his initial post, he got a lot of comments and feedback and realized that it's not a bug in the C++ standard itself. It was a bug in, I think, Clang and GCC's implementation.
Spoilers,
right?
Rob.
Spoilers. I apologize.
No, I'm just kidding. It is stated at the top. It's not actually technically a bug in the implementation. It's a missing feature in the Itanium C++ ABI that Clang and GCC follow for 64-bit builds.
Yeah. But it was, I think, a really good example of the community kind of helping someone out, because he went into this whole thing of what he thought was a bug and got all this nice feedback. And people also pointed out some really nice ways you can completely avoid this using C++ 17.
Yes, as usual, Lambdas come to the rescue.
Yeah.
I think I have like 12 episodes of C++ Weekly on Lambdas now, and like 3 more in the queue getting ready to come up. There's a lot that you can talk about with Lambdas, and a lot of ways you can use them that people don't necessarily think about.
Yeah. Did you look through this post, Gordon?
Yeah, I had to look at it. It's very interesting, actually. I think I had to look at it quite carefully. I think member function pointer template parameters isn't something I've used a great deal. But yeah, it's very, very interesting use case. And I think it's really good that that people post blog posts like this, because especially for quite niche use cases in the standard like this kind of thing, it's good to kind of spread the knowledge and kind of help identify if there is a defect in the standard or a bug in an implementation or something like that.
Well, it seemed like I'm sorry. Go ahead.
No, that's okay.
It seemed like a great way to like really get people's attention and like find out what the actual answer is. A bug in the standard. It's kind of like saying, "I bet no one could solve this problem," and then waiting to see who solves the problem for you.
Yeah, that's true. I'm not sure if that was his intention, but it worked out quite well for him.
Yeah, I don't think it was, but it definitely worked for him.
Yeah. Okay, next thing we have is Synapse, which is a new library that was submitted for Boost review. And this is like a signals library, I think similar to Qt signals and slots, right?
As far as I can tell, and also similar to Boost Signal.
Yeah.
Or Boost Slot. What's it called?
That's an interesting point. I forgot that there was a boost signals library. So how does this one differentiate to the other one? Do you know?
There is, and I've completely lost it now, but I had it up before we started the interview. There is at the bottom of the documentation a alternatives to Synapse. There it is. Compared to Signals 2.
Oh, okay.
Honestly, I'm having a hard time really differentiating the use case differences between the two of them, having even read the chart. I don't know, Gordon, do you have any insight on this?
To be honest, I've not actually used the Boost Signal library before. I've not really used signaling libraries like this.
Okay.
It looks really interesting, though. One thing I thought was quite nice is that it seems to register the signals at compile time. I'm not sure if that's something that Boost Signal does. I've not really looked into that.
Yeah, no, I don't think you.
Cool.
Yeah, I don't think you can do that with Boost Signals. A couple of things stood out to me. It does seem like if you really want to do static initialization of things, then they have macros to help with that. I don't love macros, but there's uses for them sometimes. And it seems to require that your signal and slot mechanism use shared pointer, which I'm still a little bit lost on also. Hopefully I'm reading that wrong.
Yeah, I noticed that the examples used shared pointer. I wasn't sure if that was a requirement or just a typical example.
Well, it says, by default, Synapse uses the following Boost Smart pointer components: shared pointer, weak pointer, make shared, and get deleter. So it kind of implies that it needs some sort of shared pointer functionality.
I guess I'm looking through the comparison with Boost Signals 2 right now, and one comparison they first point out is with Boost Signals 2, they use a signal of type T, whereas Synapse uses a C function pointer type def. And maybe the reason for that is that they could work with C callback APIs, because that is another difference they highlight.
That's a good point, yeah. That's probably the main driver for that.
So if you want to work with a C library, then you would want to use Synapse, because you couldn't use Signals 2, I guess.
I think the last time I had to directly deal with that was when I was using pthreads, which I strongly avoid using these days since thread got standardized.
Yeah. Okay, and then the last thing I wanted to mention was we had several guests on a couple months ago from C++ London Uni, including Tom Breza, and he reached out to me that they're going to be starting a new set of courses, and I believe the first course will be September 18th. So if you heard about that and you want to get in on, the beginning of a new cycle of courses, then September 18th is the day to do it. Okay. So, Gordon, why don't we start off by talking about SYCL? Can you give us an intro to what SYCL is?
Yeah, sure. So SYCL is it's an open standard from the Kronos group, which essentially defines a single source C++ programming model for programming heterogeneous systems. So that's systems with non-CPU devices like a GPU, FPGA, DSP, other kind of accelerators. So for those who aren't familiar with the Kronos group, they're essentially a consortium of companies similar to ISO C++ committee, which essentially work together to publish these open standards that programmers can develop to, and companies can essentially implement and gain conformance of the standard. So most people will be familiar with OpenGL and Vulkan. They're both standards from the Kronos group. Another standard from the Kronos group is OpenCL. This is similar to OpenGL, but it's a programming model for heterogeneous systems for doing sort of general purpose compute on like GPUs, FPGAs, etc. However, OpenCL is a C API with a C programming language, and it's also separate source. Meaning, so you have your host application code and then your device code, which is run on a GPU or another device, separate. And then the host API is then used to load in that source, whether it be a string or another external file, and compile it and lower it down to some instruction set for that device online as part of your application. So it's a very low level API one of the things people find with OpenCL is that it has quite a high sort of barrier to entry. It's even the kind of Hello World application can be take quite a lot of code to get going, and iterating over different approaches to a problem can take quite a lot of effort, because there's a lot of API calls, a lot of things you have to change if you want to do something different. So the aim of SYCL is it's another standard from the Cronus Group again. So the SYCL aims to sort of bring together the portability of OpenCL, so they built this ability to run code on different architectures like GPUs and FPGAs, etc., but with a more modern C++ programming model. So effectively in SYCL, when you write your code, essentially allows you to write your code that will execute on a GPU or another device as a lambda or a function object within the same application. So this is the idea of single source. So rather than having your separate host application code and your device code, it's all within the same code, your same application code. This gives you a lot of nice features, such as like type safety across host and device code. You can template instantiate across host and device, and you can also have a much like a sort of high level C++ interface. So SYCL provides a more high level C++ interface on top of the portability of OpenCL, but also provides some additional features. So it has this concept of separating out the storage and access of data, allowing SYCL runtime to essentially perform data dependency analysis in order to more effectively schedule work and optimize data locality and movement. So for example, when you describe the functions you want to run on a GPU, for example, you can say whether you want different functions to read or write from different memory, and it can do a lot of clever optimization through there. So a lot of the kind of in traditional OpenCL, you'd have to spend a lot of boilerplate code to do event management and data movement. So it kind of automatically handles a lot of that for you, which makes the kind of the iterative process of creating an application for a GPU or another device a lot quicker.
So you said, it provides like a higher level API compared to OpenCL, right? Does it require OpenCL? Does it build upon OpenCL?
Yeah, so SYCL is based on top of OpenCL, so it requires essentially it can run on any platform that supports OpenCL. Okay.
And you also mentioned, you said an OpenCL Hello World has a lot of boilerplate, and that made me wonder, what in the world exactly does a Hello World on a project like this look like? What are you actually doing in a Hello World program?
The typical Hello World on something like a GPU is usually something like a vector add. So it's like sort of taking two input arrays and adding the values together and assigning them to some output array. But even for an application like that, there's a lot of work in essentially discovering the topology of your systems, or figuring out what devices you have, configuring a context and a queue for executing work, and then you have to create the buffer objects and call APIs for copying them to and from the device, and compiling your kernel. So the device functions in OpenCL are referred to as kernels.
Okay. So how does that compare with SYCL then?
So SYCL, what we aim to do is sort of create a more high-level interface where all of the functionality that you'd have with OpenCL is still available, but we have a lot of the defaults for the most common configurations. So, for example, you can go into a lot of detail querying the different devices available on your system, configuring them in a very specific way if that's what you want to do. But we also have simple mechanisms for quickly picking a GPU. So, for example, if you're running on a system which only has a CPU and a GPU, you can create these function objects called selectors, which effectively say I want a GPU and I want a CPU, and they can be effectively used just to create effectively in one line create a queue that can run work on that device.
Okay.
But we have the more flexible options for the more complex configurations if that's what you need.
So what kind of platforms are supported by SYCL and OpenCL? Is it basically anything that has a modern GPU, or do you need like specialized hardware?
So essentially, SYCLs can run on any platform that supports OpenCL. And the list of different platforms that supports OpenCL is very long now. So it's everything from like desktop, mobile, embedded platforms, HPC. So there's the list of platforms that don't support OpenCL is a lot shorter. For portability, there's another standard from the Kronos group called SPEAR. It's the Standard Portable Intermediate Representation. It's essentially a portable IR that can be used to essentially what you do is you compile down to this IR. And it can make it a lot easier. So you'd ship that IR rather than shipping source. So that could be used. It's a lot easier for platforms to support the standard intermediate representation, because that's just lowered down to some platform-specific instruction set. But the SYCL doesn't mandate that you have to use SPEAR. Essentially, SYCL will work on any binary format that is supported by an OpenCL implementation. So, for example, NVIDIA's OpenCL implementation supports PTX, their binary format. So you can have a SYCL implementation which compiles to PTX and then runs an OpenCL through that. So it's very flexible.
So what is your specific involvement with this SYCL project?
So I've actually been involved in SYCL from almost the very beginning. So that's almost 6 years ago now.
Wow.
Back then it was actually going by a different name. It was the OpenCL high level model.
Okay.
So the group for what would become SYCL was formed about 6 years ago. At the time, Codeplay was working on a version of our offload compiler, which was essentially...
That's not the name of it. Awful compiler?
Yeah, that was the name of our compiler at the time.
Awful compiler.
No, offload. No, not
offload. Oh, offload. Oh, okay.
I also heard awful.
So we were working on a version of our offload compiler tick, which would essentially do single source compilation for OpenCL. So this was very suitable to what the Kronos group wanted. So we proposed this as a way of achieving this kind of high-level programming model for OpenCL. So over the years, I've been working on implementing Codeplay's implementation. It's called CppCP, and contributing to the standards document and the conformance test suite up until now.
I often, I would say often, it does come up where the C++ Standards Committee will approve something, and then the implementers that we know and tweet often will say, "I just tried to implement this thing and found out it's impossible." Have you done that? Have you put something in the spec yourself that you then realized was impossible to implement?
So we try to avoid that by prototyping everything. So everything that we propose for the standard, we tend to aim to prototype and test and make sure that it works well. Mm-hmm. Although it's not impossible to avoid any to catch everything. There's always some issues that kind of sneak through. So there have been times where we've had to kind of rethink things slightly to improve something that didn't work as well as we intended. It was more difficult in the beginning because when you're creating a standard from scratch, you have to implement the entire thing. So it's very fast moving. So in the beginning, things did change quite a lot. So before the first version of SYCL, things were changing a lot because we were kind of iterating over it, trying to find the best solutions. But now that it's now that kind of the standards is out, it's not changing. We're introducing new features to improve on it, but it's everything's been prototyped and to make sure that it's implementable.
Okay.
I wanted to interrupt the discussion for just a moment to bring you a word from our sponsors. PVS Studio is a static code analyzer that can find bugs in the source code of C, C++, and C# programs. The analyzer is able to classify errors according to the common weakness enumeration, so it can help remove many defects in code before they become vulnerabilities. The analyzer uses many special techniques to identify even the most complex and non-obvious bugs. For example, data flow analysis mechanisms, which is implemented in the tool, has detected a very interesting bug in the protobuf project. You can read about this bug in the article February 31st. The link is under the description of this podcast episode. The analyzer works under Windows, Linux, and macOS environments. PVS Studio supports analysis of projects that are intended to be built by such common compilers as Visual C++, GCC, Clang, ARM compiler, and so on. The analyzer supports different usage scenarios. For example, you can integrate it with Visual Studio and with SonarQube. The Blame Notifier tool can notify developers about errors that PVS Studio detects during night run by mail. You can get acquainted with PVS Studio features in detail on viva64.com. So we had, as we mentioned, Seven Brand on recently, but we also had him on about a year ago back in May. And I think we talked about SYCL a little bit then. What's changed over the past year with SYCL?
So the biggest change since then is that there's a new version of SYCL 1.2.1. So this introduces some new features to essentially better support some of the ecosystem projects that we have with SYCL. Things like Eigen and TensorFlow and things like BLAST libraries. Because while implementing Compute CPP, our implementation, we effectively had a evaluator program where selected people would get early access to sort of pre-alpha version of Compute CPP so that they could give feedback. And a lot of that feedback helped add improvements and additions to the standard. So the SYCL 1.2.1 came out I think shortly after Simon was on. It wasn't too long ago, only a couple of months ago.
So what is the future direction for SYCL that you're working on?
So for future direction, we're aiming to kind of to look to integrate SYCL even closer with C++, because obviously while we're standardizing SYCL, C++ is moving forward. So we want to bring SYCL up to date with some more modern C++ features, C++ 17 and eventually C++ 20. And we'll also continue to look to introduce new features to help improve the way people create their workflows and how they can be applied to different architectures. So we're always looking for ways to try and improve things and make things easier for developers to use. But we want to aim to have a very close alignment with the C++ standards. So if there's something that the C++ standard is introducing that we would use in SYCL, rather than standardizing something entirely new that does effectively the same thing, we would use the features of C++. So we don't want to reinvent the wheel, and when we see the C++ standard moving in a particular direction, we'll try to move along with that. So we don't want to be going against the kind of direction of the standard for C++.
Well, since you mentioned that, then what features from C++ 17 or C++ 20 are currently affecting SYCL?
How do you mean affecting?
Well, things that you want to take into account, you want to use instead of standardizing yourself, whatever.
So some features are useful just in terms of improving what you can do in device code. So things like generic lambdas, new things like templating lambdas, that would be quite interesting. More support for different forms of templates. But also we want to align quite closely with executors, and also the introducing things like futures and promises. But I'll say that the C++ committee is still debating over what different kind of futures will will be used in C++. So that's something we're watching very closely to see how SYCL will interact with that.
What kinds of futures? That sounds very, I don't know, metaphysical or something at that rate. Well, we've mentioned executors on the show, I don't know, several times, Rob, but I feel like I don't personally have a very clear picture for what that'll actually mean to the standard and how it would affect a project like SYCL. Can you go into that?
Yeah. So there's quite a few different domains that executors are aiming to support. It's one of the reasons that standardizing them is proven so difficult. So from our perspective, our domain is sort of the open standard heterogeneous systems. So things like OpenCL and SYCL. But there are a lot of other domains. That there's like networking, distributed systems, parallel algorithms, asynchronous tasking. So all of these different ways of executing work and different requirements have to be kind of unified into a sort of single approach that so everyone can write their tasks and their the work they want to perform in a unified way, but still be able to take advantage of something like an OpenCL platform, but also something like network devices and that sort of thing, and standard like thread pools.
So you have some sort of task you want to perform, and if I understand correctly, you have some sort of requirements for what kind of hardware needs to be used for this task to be executed, and then you pass that off to an executor and you say, go make this thing happen?
Yeah, effectively, yeah. So the current design focuses around this idea of properties, where effectively you can require different properties of an executor. So things like whether it does one-way or two-way execution, so whether it returns futures or not, whether it's blocking or non-blocking, how it maps to different threads or potentially GPU threads or some other device. All of these kind of properties are properties of an executor. So you can request different kind of properties, and then essentially, if the implementation supports that configuration, it'll return an executor that can do that kind of work.
Okay. So
an implementation would provide sort of different types of executors, and those executors can be customized and adapted to perform work in different kinds of ways.
Okay.
So I know you said you contribute to both the Kronos group and ISO C++. Are you involved with the executors work for C++?
Yes. So I've been involved in the executors work for the last 2 years.
Okay.
So when I joined, I think there'd already been work going on for about 4 years before that. So there were quite a few proposals already in the works. But when I joined, essentially the committee were looking for to bring all the different proposals together and come up with a unified design that satisfied everyone's requirements. So I was invited into sort of for the perspective of open standard heterogeneous domain.
Okay.
So yeah.
So how is that unification work looking? Do you think it'll make it?
It's been going very well. So whether or not it would make it into C++ 20, you mean?
Yeah.
Yeah.
Or ever.
so that's a very interesting question. The short answer is I don't really know.
Okay.
So the last meeting at Rapperswil, the new directions group made C++ executors a priority for C++ 20. And there's been some special joint LEWG and SG1 meetings scheduled at CppCon to work on this. So everyone's working very, very hard to try and sort of get to a kind of final paper that could potentially be introduced to C++ 20. But then if the alternative is if it's not ready in time, it would likely go into a TS, which would be targeted for C++ 23. it just depends how much, if we can make enough progress by the next meetings.
Right.
Do you plan on attending that special meeting that's going to be held during CppCon?
Yes, I'll be at the meeting at CppCon. I'm not sure if I'll be at the following meeting at San Diego. I'll be at the CppCon.
Okay. So, on the topic of CppCon, you have a training that you are going to be giving also at the end of the conference. Is that correct?
Yeah. So myself and Michael Wong will be doing a 2-day class at CppCon on parallel programming in modern C++, from CPU to GPU. So the aim of the course, the class, is to essentially teach people the fundamentals of parallelism and how they can apply them to CPU and GPU architectures, and how to take advantage of different kind of parallelism, and how to solve the kind of challenges you encounter along the way. So it'll likely take a sort of a pattern-focused approach. So we'll be looking at different some of the parallel algorithms and how you would implement them, how you'd solve certain challenges when trying to parallelize algorithms. So the idea is to have people leave with essentially the set of tools you need to be able to go and parallelize code in your own projects.
So what kind of tools or C++ standards will you be teaching to? I mean, is it safe to assume SYCL will be used?
Yes, so SYCL will be used as part of it. We're trying to focus mainly on existing standards, so not using anything that's still in development. So we'll be looking at C++ threads and also SYCL. We'll probably touch on sort of SIMD parallelism to some extent, but so there is a proposal for SIMD vectors in the upcoming parallelism TS2, but it's still in development, so we probably won't go into that because there's no implementations of there's an implementation of it, but there's no sort of standard implementations yet. So we probably won't go into that in too much detail.
Okay.
And then in addition to the class, you're also going to be doing a talk with Michael?
Yes, so we'll be doing a talk on SYCL. So the aim of the talk will be essentially covering a lot of what I've been talking about today, but in more detail, looking at how SYCL works and the different features of it, and how you can use the different features to take advantage of GPUs and other heterogeneous devices and C++ applications.
Is this going to be a live coding kind of demonstration, or?
So I'm still kind of working through exactly how the talk will go, but I'm hoping to have the talk kind of follow implementing some kind of parallel algorithm. So there may be I might try to do a kind of live demo of running the final application, but I probably won't do the whole thing live.
Okay.
I'm not sure if I'm that brave.
And I also wanted to ask, you're working on a C++ standards proposal. Is that correct?
Yes. So one of the other proposals that I'm working on at the moment is to introduce affinity to C++. So this is essentially on the back of the unified executors proposal, but it's kind of expanding on it a bit more to provide support for essentially querying the topology of the system that you're on, and kind of information about it, different processors, different memory regions, and being able to essentially tie execution and memory allocation to those different processors and memory regions. So it'll allow you to do things like take advantage of NUMA systems or distributed systems, but also it'll be looking more towards scaling up to heterogeneous systems as well.
So would you mind going into some more details for our listeners for what the advantage to tying affinity to a particular process to a particular system in a NUMA environment would be?
So generally, if you write an application that say runs across multiple processors across a sort of a NUMA domain, so like memory that's a single address space but distributed across multiple nodes, if the system sort of randomly allocates memory, you won't necessarily always be allocating memory that is close to where the computation is being performed. So you won't get the best performance because the latency in reading the memory will not always be as fast as it can be.
Okay.
So if you have an algorithm that sort of modifies data in a particular pattern, you can tie the memory allocation to that pattern so that you're always accessing memory as close to the process as possible. And also you can bind the processes, like different executions to those processes so that you're always executing in the same place effectively, so you don't sort of jump over to another thread on a different core or different CPU node and then have to recache copy the memory over to another node and then recache.
So generally, we try to write code that is cache friendly and stays in the local CPU cache, but you're talking about architectures where if the data you need isn't in your local CPU cache and it might not even be in your local memory, it might actually be on a completely different computer across the network.
Yeah, that's right.
Which is like, we're talking hundreds of orders of magnitude slower than if it were like right here next to you.
Yep, exactly.
Okay.
Yeah, so if you have to copy over from across a bus, for example, from one CPU node to another, then that's going to be a huge amount slower than accessing something on the local device.
Okay.
Okay, Gordon, is there anything else you wanted to go over before we let you go?
There was one thing that I was going to mention about SYCL that I kind of went past without mentioning. One of the benefits of SYCL that we like to highlight is that so there are some other sort of heterogeneous programming models that things like CUDA or C++ AMP or OpenMP, OpenACC. They all allow you to sort of do some sort of heterogeneous execution in C++ code. One of the things that we really aim to do with SYCL is that all of these programming models that I mentioned have some form of language extension or pragmas or attributes or macros in order to define the block of code that you want to execute on the device. So it means you have to introduce these changes to code, so it's not standard C++ anymore. And also these are generally tied to a particular platform. For example, CUDA is tied to NVIDIA. I think C++ AMP was only Microsoft and AMD, I think. So one of the things we wanted to do with SYCL was make it like truly cross-platform, truly standard. So all SYCL code is entirely standard C++. So any SYCL applications you run, even if you don't have an OpenCL platform available, all SYCL implementations are required to have what's called a host device. So it'll compile down to standard C++ code and run on essentially an emulated device that matches the same execution and memory requirements of OpenCL as you would have if you were running on an actual OpenCL device. So this is very useful particularly for debugging. So if you don't have, if you're on a system where you don't have a debugger for your GPU or your FPGA, for example, it's very useful to be able to run in standard C++ code the same way as you would on the device. In order to sort of debug your code, it debugs your application essentially. So it's not running on the actual device, but it debugs your application.
It sounds like even just for debugging, this would also be good for R&D. Like you could keep continuing to work on your slow laptop on the airplane or whatever while you're trying to test out how this code would look.
Yep, exactly. Yeah.
Okay, great. Well, it's been great having you on the show today, Gordon.
There's one other thing I'd like to mention, if that's possible.
Go ahead. Yeah.
Yeah. So Not as of today, but as of when this episode airs, Codeplay will have released Compute CPP 1.0, so the full implementation. So this is actually the first fully conformant implementation of SYCL that is available. And Codeplay also provides a community edition of Compute CPP that can be downloaded for free. So for that, we support multiple Windows and Linux platforms, and that also supports Intel CPU, Intel GPU, ARM CPU, ARM Mali GPU, and also we have experimental support for NVIDIA GPU through BTX. And
when is this actually going to be released?
So this will be released on Thursday, so tomorrow.
Okay.
We'll be releasing this on Friday, so yeah, it'll be out.
So it'll be out by the time this airs, yeah.
Very good.
Okay.
As always, Codeplay is recruiting, so if anyone's interested, then we have a lot of openings in sort of compilers, debuggers, runtimes, tools, etc. It's a really great place to work, and there's a lot of really interesting to happen, great people to work with. So
it does sound like there's a lot of interesting going on there.
And definitely great people to work with, because we've talked to at least 3 of them. They're all great. Okay, thanks so much for being on the show today, Gordon.
Okay, thanks very much for having me.
Thanks.
Thanks, bye.
Thanks so much for listening in as we chat about C++. I'd love to hear what you think of the podcast. Please let me know if we're discussing the stuff you're interested in. Or if you have a suggestion for a topic, I'd love to hear about that too. You can email all your thoughts to feedback@cppcast.com. I'd also appreciate if you like CppCast on Facebook and follow CppCast on Twitter. You can also follow me at Rob W. Irving and Jason at LeftKiss on Twitter. And of course, you can find all that info and the show notes on the podcast website at CppCast.com. Theme music for this episode is provided by podcastthemes.com. Website at CppCast.com. Theme music for this episode is provided by podcastthemes.com.